Geothermal energy and electricity generation, exploring the process. Geothermal energy and electricity generation, exploring the process. In the quest for sustainable forms of energy, geothermal power has emerged as a viable option. With its ability to generate clean, reliable, and cost-effective electricity, geothermal energy is game. At attention worldwide. Geothermal energy is derived from the Earth's internal heat. This immense heat is a result of the radioactive decay of minerals, as well as the residual heat from the planet's formation. In certain areas of the world, this thermal energy can be accessed relatively easily. This includes regions located near tectonic plate boundaries or areas with volcanic activity. The process of geothermal electricity generation begins with the identification of suitable geothermal resources. These resources typically include underground reservoirs of steam or hot water. The first step in the process is drilling a well into the geothermal resource, which can reach depths of up to several kilometers. The well brings the hot water or steam to the surface, where it is used to generate electricity. The fundamental principle behind geothermal electricity generation is the conversion of the thermal energy from the geothermal resource into mechanical energy and then into electrical energy. This is achieved through a series of steps involving various types of equipment. At the surface, the hot water or steam passes through a separation system. This system removes any impurities, such as minerals or gases, from the fluid. The purified hot water or steam is then directed towards a turbine. The turbine is a crucial component of the geothermal power plant. As the hot water or steam flows through the turbine, it causes the blades to rotate. This rotation transforms the thermal energy into mechanical energy. The turbine is connected to a generator, which is responsible for converting the mechanical energy into electrical energy. After passing through the turbine, the cooled water or steam is condensed back into a liquid form. This condensed fluid is then injected back into the geothermal reservoir through a separate well, it will be reheated and reused in the process. This closed-loop system ensures the sustainability of geothermal power generation by utilizing the same resource continuously. One of the significant advantages of geothermal energy is its reliability. Unlike solar or wind power, which are dependent on favorable weather conditions, geothermal energy provides a consistent source of electricity. Geothermal power plants can operate continuously throughout the year, providing a steady supply of electricity to the grid. Additionally, geothermal energy is exceptionally clean and environmentally friendly. It produces minimal greenhouse gas emissions and has a negligible impact on air quality. Compared to conventional fossil fuel power plants, geothermal power plants have a significantly lower carbon footprint. Furthermore, geothermal energy is cost-effective in the long run. Although the initial investment required for drilling and constructing geothermal power plants is high, the operational costs are relatively low. The fuel source, in this case, the heat from the earth, is essentially free. This makes geothermal energy economically attractive, especially in regions with abundant geothermal resource. However, there are certain challenges associated with the widespread adoption of geothermal energy. The location of suitable geothermal resources is limited to specific areas of the world. This restricts the availability of geothermal energy to a relatively small number of countries. As a result, the development of geothermal power plants requires careful resource assessment and exploration. Furthermore, drilling deep into the Earth's crust poses technical and logistical challenges. The process of drilling and maintaining geothermal wells can be complex and costly. The risk of encountering issues, such as drilling accidents or the release of harmful gases, must be carefully managed to ensure safe and efficient operations. Another challenge is the potential for resource depletion. Overexploitation of geothermal reservoirs can lead to a decline in the availability of thermal energy. Proper management and monitoring of geothermal resources are essential to avoid depleting these finite sources. Despite these challenges, the potential of geothermal energy for electricity generation remains significant. Advances in technology and ongoing research are continuously improving the efficiency and accessibility of geothermal resources. Moreover, geothermal energy can contribute to energy diversification and reduce reliance on fossil fuels, thus improving energy security on a global scale. Geothermal energy has gained worldwide attention as a viable option for sustainable electricity generation. This form of renewable energy utilizes the Earth's internal heat, which is a result of mineral decay and residual heat from the planet's formation. Areas near tectonic plate boundaries or with volcanic activity are known to have accessible geothermal resources. The process of geothermal electricity generation begins with the identification of suitable geothermal reservoirs. These reservoirs typically contain underground steam or hot water. A well is drilled into the resource, reaching depths of several kilometers. This well brings the hot water or steam to the surface, where it is used to generate electricity. The conversion of thermal energy into mechanical and then electrical energy is the fundamental principle behind geothermal electricity generation. This conversion occurs through a series of steps I and V, involving different types of equipment. At the surface, the hot water or steam passes through a separation system to remove impurities. The purified fluid is then directed toward a turbine. The turbine, a crucial component of the geothermal power plant, rotates as the hot water or steam flows through it. This rotation converts thermal energy into mechanical energy. The turbine is connected to a generator, which converts the mechanical energy into electrical energy. After passing through the turbine, the cooled fluid is condensed back into a liquid and re-injected into the geothermal reservoir through a separate well. This closed-loop system ensures the sustainability of geothermal power generation by continuously reusing the same resource. Geothermal energy offers several advantages. It provides a reliable source of electricity, unlike solar or wind power, which depend on favorable weather conditions. Geothermal power plants can operate continuously throughout the year, ensuring a steady supply of electricity. Moreover, geothermal energy is environmentally friendly. It produces minimal greenhouse gas emissions and has a negligible impact on air quality. Compared to fossil fuel power plants, geothermal power plants have a significantly lower carbon footprint. Geothermal energy is also cost-effective in the long run. Although the initial investment for constructing geothermal power plants is high, the operational costs are relatively low. The fuel source is essentially free, as it comes from the Earth's heat. This makes geothermal energy economically attractive, especially in regions with abundant resources. However, there are challenges associated with widespread geothermal energy adoption. Suitable geothermal resources are limited to specific areas, restricting availability to a few countries. Developing geothermal power plants requires careful resource assessment and exploration. Technical and logistical challenges arise from drilling deep into the Earth's crust. The process of drilling and maintaining geothermal wells can be complex and costly. Proper management is crucial to ensure safe and efficient operations, as issues like drilling accidents or harmful gas releases must be carefully managed. The potential depletion of resources is another challenge. Overexploitation can lead to a decline in thermal energy availability. Proper management and monitoring are essential to avoid depleting finite sources. Despite these challenges, geothermal energy holds significant potential for electricity generation. Ongoing research and technological advancements continue to improve efficiency and accessibility of geothermal resources. Geothermal energy can contribute to energy diversification and reduce global reliance on fossil fuels, thus improving energy security. Geothermal energy and electricity generation have gained significant attention in recent years as a viable solution for sustainable power generation. This form of renewable energy utilizes the Earth's internal heat, which is a byproduct of the radioactive decay of minerals and the residual heat from the planet's formation. Areas located close to tectonic plate boundaries or with active volcanoes are known to have accessible geothermal resources.